Hello friends, today we are going to see the Kubernetes 2 replica. It's a replica controller and replica set, which in normal term you can say it is the brain of Kubernetes. There are many, but we will see these two today. So before starting that, first we will understand that what and how the Kubernetes works. So in Kubernetes, main role is to keep monitoring these pods. What is pod? I will say in few minutes. So control the pods, monitoring the pods, and if any pod fail, it will launch a new pod for you. If the requirement is there that you want more pods in future, it will give a replica of these pods. This whole control and monitoring part is done by the Kubernetes of this pod. So let's see what is this pod. So this pod is just like a box, you can say. In it, we keep container of a Docker means you can see operating system is there. And in it, we keep application in Docker we use images. So okay, you can say that here I had a HTTPD for server, here I have MySQL for database, here I have PHP, WordPress for front-end work. So all these are coming in one pod and Kubernetes are managing this. Okay, so if any pod fails, the Kubernetes will launch for you according to the requirement. According to the requirement, it will double increase the pod also if requirement is there. Okay, so we are going to see that replication controller and application set part. So in Kubernetes, we write the code in two ways. In CLI we write, and we write in a manifest file like JSON language or YAML language. So, but all the resources can't be created by command line. So because of that, we are going to use a manifest file for replication controller and application set. Okay. So before starting that, we will see that how Kubernetes is managing the pod. So there are two based labeling, means selector types are there. So equality based labeling, this is this comes under our application controller, means application controller manage the pods by this technique, this way. This equal to means you can say that we have given a pod name and given a label. Like in our case, we have given a label of production. Okay, we have given this pod name and label as a production. Okay, and also I want to see that whenever any pod terminate or fails, the pod name changed every time and label doesn't change. Okay, I'm saying in controller, means replication controller and in replica share set. Okay, so because of that we are giving a label so that it keep on monitoring the pod. Okay, so equality based means if the pod label is equal to production, so it will give you the whichever the pod has a production labeling, it will show you that pod. In real world there are thousands of pods are there, so manually searching, it is very difficult job. So because of that, this technique of this labeling, equality based labeling, is very useful for us to finding out the which pod where it is working in, or how is it working. And if we want that a pod whose labeling is not equal to production, and that pods are not in India, like we have given a label of India, so it will show you that pods. So according to the requirement, we use this labeling. You can say this as a selector also. Okay. set rule based labeling. This we are going to use in replica set. It is a new way to do a labeling or monitoring of a pod. Like if in our case the environment is production, so it will find pod where in production is there, please show. So it will show you that pod, and where the pod is not in production, it will show you the pod which are not in production. Okay, so these are the main part of the replication control and application set. So we are gonna start with the practical, that how we are gonna do a practical. Okay, so in my case, the all files are on desktop and all in folder K8s. Okay, you can see. So we are gonna make everything here, and before starting that, we'll check that is there any codes are there created or not. So it is taking time to find out that is there any codes are created before. So yes, the pods are created. So I will delete all and clean the environment. So this is very critical command. By this, the whole environment will get clean. So in real world, we don't use that. We use, but not that much. So it is taking time. It is deleting. So we are gonna use a manifest file, YML file in this practical. And why we are using manifest file? Because we are using two languages, that is applications, that we are using kubectl to write a code, and this kubectl goes into my VM where my Minikube is running, and in it the Kubernetes is there. So to transfer the code from kubectl to Minikube, this way we have to approach. Okay, so because of that, we use a manifest file so that it becomes more easier. In command line, we can't create all the resources, so because of that, we use a manifest file. And here, if your API server is working, then only you can do this. This manifest file is going to work. So how you're gonna check that is your API server is working or not? You can type this Minikube status. It will show you that your API server is running or not. It will show you. It's taking time. So yes, here you can see that your API server is running. So whatever you write in YML file, it will go over there. In my environment file also we will use API server. I will show you. So I will open a YAML file of replication controller. First we are going to do a replication controller, and then we are going to move ahead with replica set. So I had already created a file. Let's see. So here API version :v1 means we have to write this every time while we write a YAML code in replication controller or replication set. In replication set is a newer version, so over there we are going to use a newer application API version. So I will show you. And these are the replication controller. It is our resource. So every time we write a resource in a keyword called kind, and in YAML file the code we write is like we first write a key, okay, and after that we give a colon, and after one space we write any value, okay. And kind is our kind we type a resources. So our resource is a replication controller. I mean, we're going to use a replication controller here. And metadata, you can give any name according to your wish. I had used a myweb RC, okay. And in specification means these are the creation of job, you can say it. That replicas means it will create 3 replicas of your code. And selector means it's going to do a monitoring of environment called production. It will do a monitoring or as per the label or selector we have given, okay. Means if the pods we have given the label as many, but it will do a labeling of that pod which have environment production, okay. So this is one label of pod, okay. And here we have given a name of our resource here. Our resource is replication controller, and we have given a small name. You can give any name you want, okay. So this come under metadata. And specification means task or duty that they are going to perform. Means replication controller, that task or duty is going to perform. Means it will do a replication of a pod. It will give a label to a pod. Templates also comes under it. And we give a name to a pod, that what would be our pod name, okay. And we have given a pod a label, okay. So please understand that here we are giving a label that a replication controller is going to monitor. If you don't give this label, it is not going to monitor this pod that we are creating here, okay. And in the pod, what we are going to keep, like I had shown you in a picture, that it is our pod, okay. And we have given a name, a label. You can see here we have given a name to a pod, and also we have given a label to a pod, okay. And inside this, what container we are going to put, okay. So that only your written, that also a part of a template. So container, so you can give any name. So it is my web -com. You can't use underscore, okay. And the image in Docker, we have image. We use image in Docker, so we are gonna use HTTP image, okay. So this is the full code of replication controller, okay. So I will save this it is already saved. We'll run this code. Okay, kubectl create -f. F means folder. Which folder? rc1.yml. Okay, so it will create pods. So pods is created. So we'll see that how many pods created. Unable to connect to server. Internet is working. Yes, you can see that container creating. So creating means it is downloading the image file and doing this part. So it will create in some seconds. Yes, created. You can see that 3 pods are created. So if you delete any pod, it will launch that pod again for you. So let's see the labeling, that what labels are given. So you can see that here the labels are given: environment production, environment production. Okay, so if I delete any code, what will happen? Let's check. kubectl delete pod name. So I will copy this. Paste. So it's going to delete. Yes, it is deleted. And now I will check that Kubernetes will going to create this pod or not. It's taking time. So okay, yes, you can see that this pod got deleted, but again it got created in 45 seconds. The rest is other. Okay, so this is the main role of the replication controller, but it is now older. Means in company most of people are not using, and it is going to absolute in future. Okay, so now we are going to see the replica set. So we will first clear the environment. So kubectl delete all. So it is going to delete everything, means pod also and replication controller also. If it is got deleted, so in future it is not going to monitor or control any pod. So it is deleted. So the main role of this both replication controller and replica site is to launch a new pod if anyone get failed or terminated. Okay, if according to the, you can give a desire, okay, how many pods you want, If you want 3, 4, 5, you can give any number. Okay, and also do a monitoring of the pod, what's going on in the pod. So we'll open a file of a manifest, replica set manifest file, which I had written notepad rs1.yml. So here it is. So the writing of code is similar to the replication controller. Little bit difference or a little bit changes there. So I will explain what changes is there. So API version here, the API version replication set is using is apps v1. It is a newer version, and the API version which we were using, that v1 is older version. And in kind we write a resources, means our resource is a replica set, means this whole duty is going to perform under replica set. What duty? That it is coming ahead. And what metadata, what name you want to give to your replica set, so we are giving a myweb-rc. Okay, and now the duty parts come in the specification. So replica, so we'll change here 5. Okay, so in replica, if you increasing your pod from 3 to 5, means it is a desire that you are giving a desire. So this we call scale out. And if you decreasing, means from 5 to 2, from 10 to 5, then that we call scale in. Okay, so here we are giving a desire of 5 to create a replica for pods. Okay, and in replica set, the selector or labeling which we give is in this way, is like expression way, which we write in a Python. Also you know a little bit. Here we write match expression. Okay, in it we write key. Our key is environment. You can give any name you as per your requirement. Environment is our key, and it is our value, means it is our label. It is key and our value, and it is an operator, means where the environment is there in production. Okay, so in production, where the environment is production, the replica set is going to monitor that one. Okay, and templates, in it we are giving a name of our pod, metadata. So here our pod name is mywebpod, and we are giving a label to a pod production. Okay, if you don't give a label of production here, so replica set is not going to monitor this. Okay, so we are giving name and pod, and I told you that this name is changes every time. I will show you. Here you can see it, that name, that your name is getting changed, that which one we deleted, TT, yes, that you can see that name is changed, but the label is not changed. So they do the managing or control or of a pod by labels. Okay, so label is very important in Kubernetes, and we are giving a label. Environment is a production, and under this we want a container. If you don't give a container, what is the use? So we are giving a container and giving a name of a container. You can give any name according to your wish, and we are using the container of image http. Okay, so that's it, the code part. So it is already saved, I think, so I'm not going to change it. Okay, So I will create a pod using file called rs1.yml. So it is created in backend, it is creating, and to us it is showing that yes, it is created. Let's see the tables. And my environment is clean. All the previous pods and replicas app controller all get deleted. So you can see that container is creating and is downloading that image. In a few seconds you're going to see that yes, it is running. So it's taking time, it is downloading that image in a pod. We have given oh, actually I had changed that part. We have to change. Okay, I have to save that part also, because in Replica I had given desired file and I haven't changed. So I will change. So let's start there. Do this on the continue this way. Okay, so you can see that it is created and all are running successfully, and the name is given here, rs. So let's try to delete any pod like kubectl delete. I'm going to delete this pod. Okay. The server doesn't have a type. I just show this. Okay, I have to give a pod name as pod. So it is deleted, you can see. So we'll check that replica set created again or not. That get you can see that it is created, and in 20 seconds they created. Okay, this is new one and this is older. So now we will do one small quick practical. Let's create a fresh environment. Delete all. We're going to delete kubectl. Okay, so it is deleting. So I'm gonna create a new image using I'm not gonna use that YML file. I will create a pod using CLI, and we'll check that if I give a same environment name means label of which I have given in a replica controller file, what will happen? It is going to merge with that file, or it is not going to merge that. How many pods is going to create? 3 or 4? How many? Okay, so kubectl run what's that pod name? Kubectl. Okay, my pod. You can give me my pod 2034, and we have to give a label image also. Image equal to httpd, and this I'm creating in CLI, and labels equal to environment equal to production. Let's check it is exactly same or not. Yes. So this I'm creating in CLI. So this is created. So I'm creating this pod in CLI, means I have given a name, my pod 1234, and the image I'm gonna save. Means I have created this pod of name my pod 1234, and in the image in the container, and I'm using httpd. Okay, I typed wrong, https, so I have to change, and the label of the pod I have given production. So I have to change that to delete that too also. Okay. So here we go, it is created. You can check that is it created or not. Get pods. Yeah, it is running successfully and 11 seconds. So now I'm gonna use a replication controller. Any file you can use, replication controller, replica set. So let's change to 5. Okay, so we are creating 5 replica of this pod where the label we are giving is production. Okay, and we already created one pod in CLI and given a labeling name same as the replica set here. Okay, I'm going to open the replica set. Let's change to replica controller. You can use anyone, but I'm using this only. Let's see. Let me change it to 5. So what will be the result? Will I get a 6 pod, or will I get a 4, 5? Well, let's check. And I'm gonna save this file. Okay, kubectl create pod of folder called name rc1.yml. So it is created. Let's check how many pods it is there in your Kubernetes. kubectl get pods. So it's taking time. So you can see that the only 4, 5. So it merged that with replica controller. So you can see the power of this controller. You can use anyone. Replica set also you can use. Replica set is a newer version, and deployment behind the scene using replica set only for monitoring the pods. Deployment is also any open resource which we are gonna see in future how it works. So you can see that yes, there are 5 pods we created, and in replica control file we have given 5 replica, and this one we have created in CLI, but replica controller took that in his manage in his control. Let's delete that part. Will it create that code or not? Okay, sit here, delete code, my code, 1, 2, 3, 4. Okay, it is deleted. So now we are going to check that the replication controller is going to create that code or not. This it should create. Yes, you can see here 1, 2, 3, 4, 5. It is creating that ports. Okay, so he took that code under his monitor. That my code 1, 2, 3. Now the name is changed, but you will see that the label is same. Environment production. So the main point is that they are monitoring or controlling the pods using label selector only. So this part is very important in Kubernetes. So that's all for today. So we cover the replication controller and replica set today. So in future we're going to see that how deployment work. Okay, thank you.